Hello students, welcome to chemistry classes. So under this hydrocarbons, today we are going to discuss the chemical properties of aromatic hydrocarbons. First of all, the electrophilic substitution reactions of benzene. Nitration reaction. So nitration reaction is carried out with the help of nitrating mixture. Nitrating mixture is concentrated nitric acid and concentrated sulfuric acid. So from this, nitric acid is the reagent and sulfuric acid is the dehydrating agent. From the nitric acid, it is written like this, OHNO2 and H plus HSO4 minus. So this bond is shifted towards the OH group, OH minus acquiring negative charge. The negative charge abstracts this proton of sulfuric acid, so it replaces in the form of sulf water. So the resultant nitronium ion is formed. Nitronium ion, the nitrogen atom, this ions having the positive charge, therefore it acts as a electrophile. Therefore, electrophilic substitution reaction can be takes place in the benzene ring. Electrophilic substitution reaction. How this nitration reaction takes place? So one of the hydrogen atom. So this bond containing this bond move towards this benzene ring. So it acquires negative charge. So we are treating with NO2 plus. NO2 plus. So now this part carrying the negative charge attract this electrophile. Hydrogen atom is cleaved from the substrate. So it gives NO2. Nitrobenzene. H plus is regenerated. This H plus combines with this HSO4 minus. Again it gives sulfuric acid. Nitration reaction leads to the formation of nitrobenzene. This reaction is carried out under the conditions 322 to 353 Kelvin. 322 to 353 or 33 Kelvin. So this is the electrophilic substitution reaction, that is the nitration. The next is halogenation. The second reaction is halogenation. Halogenation, either bromination or chlorination or iodization. So here also the benzene reacts with the chlorine in the presence of anhydrous aluminum trichloride. The chlorine hydrolytic leverage of bond leads to Cl minus and Cl plus. The Cl minus abstract this AlCl3 to form AlCl 4 times minus. So the similar way, this hydrogen, this bond shift towards this benzene ring and carries negative charge, it abstracts the proton. This reaction is called electrophilic substitution reactions of benzene. Chlorobenzene is formed. Suppose we are adding bromine and anhydrous aluminum tribromide or aluminum bromide, it gives bromobenzene. Bromobenzene is the product. Sulfonation reaction. The next is sulfonation reaction. Sulfonation reaction can be carried out with the help of fuming sulfuric acid. Fuming sulfuric acid is a powerful dehydrating agent. Itself, it eliminates the molecule of water. So it gives H2O and SO3. we use neutral electrophile for this sulfonation process. Benzene reacts with fuming sulfuric acid. Benzene reacts with fuming sulfuric acid. It gives benzene sulfonic acid, SO3, and hydrogen is added here. Benzene sulfonic acid as the product. So, this is very important in the examination point of view as well as in the entrance examination. Sulfonation reaction, most of the cases sulfonation reaction can be carried out with the help of neutral electrophile called SO3. Okay. Then Friedel-Crafts alkylation reaction, Friedel-Crafts alkylation reaction, Friedel-Crafts acylation reaction. Alkylation means the alkyl group is introduced to the benzene ring. The Friedel-Crafts alkylation reaction means benzene reacts with either methyl chloride or ethyl chloride, in the presence of anhydrous aluminum trichloride. It gives methyl benzene or ethyl benzene, CH3 plus HCl. This is C2H5 plus HCl. This is methyl benzene is called toluene, ethyl benzene, the second one is the ethyl benzene. Benzene reacts with either methyl chloride or ethyl chloride in the presence of anhydrous aluminum trichloride gives methyl benzene or ethyl benzene. So, alkyl group is introduced during the course of the process, therefore, this reaction is called Friedel-Crafts alkylation reaction. The next is Friedel-Crafts acylation reaction. The same benzene reacts with acetyl chloride. This compound is called acetyl chloride in the presence of anhydrous aluminum trichloride. It gives acetophenone. This chlorine and this HCl is replaced. The remaining group, that is called acetophenone. Acetophenone as the ketonic compound. Suppose in the place of acetyl chloride, if you are using acetic anhydride, this compound is called acetic anhydride. The same acetophenone and byproduct is acetic acid. Acetic acid is the byproduct. So, this reaction, this CH3COO and this H replaced in the form of acetic acid. So, this reaction is called Friedel-Crafts acylation reaction. But benzene reacts with the excess of chlorine. Benzene reacts with the excess of chlorine in the dark condition, and the dark condition in the presence of anhydrous aluminum trichloride gives hexachlorobenzene. Hexachlorobenzene is a substituted product formed. Hexachlorobenzene is obtained. Benzene reacts with the excess of chlorine in the dark condition. Benzene reacts with the chlorine, excess of chlorine. Dark condition, it gives Cl. Benzene hexachloride. Benzene hexachloride is a compound formed during the course of the process. So, these are the normal chemical reaction, especially the substitution reaction takes place in the benzene ring, and some addition reactions also takes place, because it consists of 3 unsaturated pi bonds. It reacts with 3 molecules of hydrogen in the presence of nickel as the catalyst. it gives cyclobenzene as the product. Benzene undergoes addition reaction, it gives cyclohexane. Cyclohexane as the product. Benzene reacts with here also benzene reacts with excess of chlorine. Excess of chlorine. In the light, this is the dark condition, this is the light condition. It gives the compound called all the hydrogen atoms are replaced. Benzene hexachloride. This compound is called benzene hexachloride, BHC, Camexene. And benzene on combustion gives carbon dioxide and water. Combustion of benzene gives carbon dioxide and water. So, these are the important chemical properties of aromatic hydrocarbons. So, I hope all this understood each and every people. If you have any doubts, you may ask. Thank you.